How's it going? This is Dr. Schulman, and this is how to use tools and calculators in the math classroom. This one is, I think, one of the most useful ones that you can do. Hopefully, you picked this one. If you didn't, that's okay. I'm sharing my screen, and we're going to talk about it. We're going to talk about how we can use tools and calculators in the math classroom. Um, Now, this whole idea, especially for younger students or students all able, like you want to get their hands in the math. You want to get their hands in the math as much as you can. So, while technology can help advance the discipline of mathematics and provide simulations of complex and sequence calculations and connections between visuals of polar or Cartesian graphs to the equations in easily digestible format. So, technology helps us out a lot. All the time, I'm doing this. No matter what we're doing in the class, I want my students to see it. And I want to give them a reason for what it means. So 3x minus 5, right? Boom. That's what it is. Let's see it, no matter what it is. It could be a rational function, 3x minus 5 divided by, divided by 2x plus 3. I can show my students exactly how this was created, right? It could be as simple as a line, as complex as a rational function. It could be even ones with slant asymptotes. Ooh, let's put a slant asymptote in there. Boom. Here, let me show you. There it is. Now it's a slant asymptote as well as a vertical asymptote. We can have a bunch of pieces. Now we can do ones that if this is squared, well, if this one is cubed, yeah, so I can show my students how to build any one of these, which I think is really interesting, but that's just me. We're all different, right? Um, so technology is super useful, but yet learning about measuring and grasping fundamental concepts are aided by tools, just regular hands-on tools, rulers, protractors. So whether we're trying to get a length, finding an angle, a compass, geoboard, one of the most things that my students do is I have them try to challenge each other by drawing angles and see which one can. I'll be like, give me 43.5 degrees. Have them draw it and see if they can be closest, who's closest by finding the angles. Three-dimensional shape models are great for surface area and volume. I've shown the altitude trackers for generating values for trigonometry. You can work with snap blocks, converting tens places, all these shape manipulatives to unlock symmetry fractions. I use dice, I use cards for probability, a calculator to check my computations. Students, we should be teaching them how to use the tools. A lot of times students don't even know how to use the calculator, and we should be giving them time with that. So simple activities like having students draw acute, obtuse, or reflex angles, then using protractor to see how close they were, or drawing a straight line. Oh, the other one is like draw a straight line. Who can give me 3.2 centimeters and have them all draw the line and measure them? I was inspired by the math teacher's handbook for those, which I thought was great. I'm always going to shout people out for because I'm trying to make a handbook myself for people who do it better. So they gave me the idea for the ruler one. Hands-on activities where students get to utilize tools to build knowledge can help make more engagement, provide practical use and critical thinking skills. With each tool, make sure to take the time to teach students to use it and its importance. Also explain its origin. Like, where did the protractor come from? Who made it? Why? To ensure students can feel confident using their tool again in new situations. Many tool uses seem obvious. However, I've watched many students make errors with everything from rulers to calc. Yes, I have. Stating that they never learned or were taught how it works. In addition to providing comprehensive directions for each tool, divide methods for students to check their tool use. Like, how can we check it? How can we calibrate it? So you could read this paper I wrote, which goes beyond symbols and tools to promote deeper understanding of math concepts. I don't think it's too long, but I know this one I did a really good job at. It's 10 pages. Well, it's 8 pages, but I think this one is really well done. Basically, I use constructivist ideas and philosophical approaches. I share how the process of the internalization of mathematical ideas can be formed in students. Teaching on how to teach someone adequately is a metacognitive idea that requires deeper thought on processes. The paper describes how learning can be crystallized. So like, how can we solidify learning through the senses, experiencing, modeling, and tools together? So it's really well done, and it goes through it. So there's an endless amount of tools, right? How many did I pick? 11? Yeah, I got 11 in the calculator. So there's 12 to look at. Okay. While there are an endless amount of tools to choose from, I picked 12. Below are specific ways that I found to incorporate tools with the classroom. Read through each tool and use and activity described below. In addition, feel free to look through these virtual manipulatives. I love virtual manipulatives. I think they're great. So just to show a student how a protractor works, you can see it happening and with the degrees on, ta-da. So do they have a geoboard? Yeah, I like geoboards. So here's a geoboard with colors. So we're just putting colors around this geoboard to make shapes. What else we got? Dun, 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 dun. Area and perimeter. Oh, geoboard shape. That's cool. Yeah, nice. So here's a geoboard shape. You could hit trash to start over, right? Yeah, cool. Okay. So the first one is the rulers and tape measures. Now this one was based off of Al-Kozi's Ancient Egyptian. One I just went deeper into it. So the lesson has students read about the Egyptians and history, watch a video, and then measure each other using rulers and tape measures. Then the students convert their values and draw themselves on graph paper. And then they can dilate their images onto larger than life paper to create large scale versions of themselves that would decorate the walls of a pyramid or your classroom. The lesson not only teaches students how to use a ruler and convert values, but it's also a safe way to bring up potential students' body image issues. I didn't know this until I started doing this one, that girls found it really useful for their body image issues, as often some of their parts were in perfect proportion to the pharaoh. So you can see the lesson. I think it came out really well. It's got lots of gifts because that's how I teach. See, the headdress is moving, the eyes are moving. We teach them how Egyptians measured using cubits from the forearm to the tip of their finger. A palm was 4. You should have, I think it's 7 from the, for 7 palms make a cubit. So that's from the elbow to the tip of your finger. A foot was actually a foot, right? So all this stuff's important. So they get to read about it. And then they get to measure each other, which I think is great. And then they get to watch the video. This is the actual temple it's referencing, all the coordinates, and then they get to answer the critical thinking questions. What fraction of a cubit is 1 finger? Are there 7 palms to your cubit? So are there 7 of these to go from your elbow to the tip of your middle finger? And how were they so accurate? And then you get to show them a video about how the pyramids were made, and then make sure the tape measure is perpendicular to the ground, using what? The math vocabulary, and they get to fill this out and create their own pharaoh. And then they can dilate it if they like, and then they could do the other part. So this is, I think, is really interesting for students, really useful. So, all right, so that one was fun. Now for protractors. So Hardison and Lee have created a series of differently shaped protractors. This one is fun to just teach students like how would these work, which ones are useful or more useful, different shaped protractors. It's a great way to like have students see different types of protractors. So students have used a variety of means to check to see if these tools are useful, right? They have to use the crazy ones and see if they're actually useful. The one that I always end up using to teach students how to use the protractor is the pool lesson, where students basically have pool setups and they have to see using the protractor if it is going to go into the what? is it going to land inside of the hole? And if you want, you can go and watch the Donald Duck video that shows it too, which is really cute for students. Compass. So compasses are tough for students. So the construction of shapes is a great way to have students a great way to have students experiment with using a compass as well as a protractor, right? So can they make a shape? So this activity handouts are all created by Patterson. One is with reflection, one is with rotation, and one is with translation. So each of these, right? Each of these requires students to construct the geometric shapes using the compass, okay? I think they're really good to teach rotation, reflection, and rotation. Constructions, I think, are really useful, and then you get to end after using the compass with the protractor. So I think this one's really well done. These activities, I have some other ones, right? I know I have some more of these. Yeah, here's a good one. Using trace your items onto patty paper, which is transparent paper, make predictions. And then I have the answers on this one, but I think it's just really good. So this is a good one. So students check their work by using the patty paper to just see if it matches, right? So if they did the translation of the shape and they rotated it, so this is a rotation one. They bring it over here. I think this one has all three. Do they actually have the right shape at the ends? After understanding how to use a compass, they can be utilized for better visualization. So this one's the sector one. So it spins all the way around and like it really helps students to understand it. Okay, so that's a compass. Make sure you get the safe ones that don't have the sharp ends. So your students don't hurt each other, but I think really showing them how to draw with a compass is big. While virtual geoboards exist, there are many options for actually using the geoboard. So I have used geoboards to find area-specific shapes. Here are, this one was number 7, but here's 18 ways you can use your geoboard. This is what the geoboard looks like. I did number 7. Where's 7? Oh yeah, so you basically have this to see the area of squares, perimeters. You're just using geoboards to teach about area and perimeter, which I think is really useful. However, there are many possible games. Oh yeah, here's a bunch of geoboard challenge games with open-ended questions. Other ideas can be combined with fraction talks. You can use your geoboard with fraction talks. I've never seen fraction talks. They're great. It's a bunch of shapes. And you have students figure out percentages and fractions and ask them a bunch of questions based on it. Too bad Jamboard's going away, so I'll be downloading this guy. All right. Awesome. So coins, dice, and cards. The sample space of probability can be difficult for students. Whether using I've used giant playing cards before, actual number cubes. Students get a better sense of how odds and statistics work as they experimentally construct them right in front of them. So this Gambling Labs is probably one of the best things I've done. I found this thing. It's so great. I taught in Vegas for a long time, and they loved it. So the first one is craps, and you get to roll the dice and do the win or lose based on that and figure out the probabilities. We've got Monty Hall. We have coins, dice, and cards. We've got roulette. You teach them how to play roulette. All the probabilities, you can teach them to play Plinko, where it drops in the slot, and where is it going to fall. And then they get to make their own, which is super fun. Students making their own gambling games were great. And they actually had to develop their own, which I thought was awesome. It really pushes students to delve deeper into exact statistics of possible outcome. Here's an image of, oh yeah, this is one. So I asked them to create their own game with their own rules. This was Rainbow Roulette. It was more fun than regular roulette, and it was harder, because they had to actually get the right answer. So they made their own roulette board, and they had to show me all the probabilities and how to play the game. There was tons of these though. They all came out good, but I would always display all of their work outside of the classroom so everybody could see everything that was going on so they could get more excited about math. I've also used Uno cards to explain proofs. And okay, so to bring trigonometry in the real world, I've had students measure the height of a school flagpole, which you can do just with similar figures. However, I wanted to take the idea further when teaching about sine, cosine, tangent. So using this rocketry STEM lesson, students build their own rockets and fire them off. And this was how to build the altitude tracker and so two students stood at different positions to determine the exact height of the rocket choosing an average. Here's a funny fail video of my students not being excited when it happened because the countdown, they're really bored. And there's me doing it. Let's turn off the sound but you can watch it. So she's counting down. This is just somebody filming while I was doing it. We got a bunch of students out here. Actually, no, we can listen to it.
Hi. Girl,